pump performance curve. And similarity rules. Since the theory of the previous section is rather qualitative, the only solid indicator of a pump's performance lies in extensive testing. For the moment, let us discuss the centrifugal pump in particular, the general principles pumps will be discussed here. The general principles and the presentation of data are exactly the same for mixed flow. Same. For mixed flow and axial flow pumps and compressor. Performance chart are almost always plotted for the constant shaft rotation speed n. The basic independent variable is taken to be discharge. The basic independent variable is taken to be discharge Q the dependent variable or output are head H, pressurized delta P for gases, pressurized brake horsepower, bhp as discussed before, and efficiency. Eta. For example, this picture shows typical performance curve for a centrifugal pump. The head is approximately constant at low discharge and then drops into the zero at the head diagrams. Qmax. So Qmax is for the head equals to 0, and also efficiency. At this speed and impeller size, the pump cannot deliver any more fluid than Qmax. The positive slope part of the head is shown dashed. As mentioned earlier, this region can be unstable and can cause hunting for the operating pump. This area. The efficiency eta is always 0 at no flow and at Qmax, and it reaches a maximum perhaps 80 to 90% at about the 6/10 of Qmax, this point. So we have eta max will be accurate at the Q equals to the 6/10 of Qmax. This is the design flow rate. Q star. Our base efficiency point. Efficiency point, which shown with BEP. The head and the horsepower at BEP will be termed at H star and P star. It is desired that the efficiency curve be flat near the eta max, this point, so that a wide range of efficient operation is achieved. However, some designs simply do not achieve flat efficiency curve. Note that eta is not independent of H and P, but rather it is calculated from the relation eta rho G Q on H on P. As shown in this picture, the horsepower required to drive the pump typically rise monotonically with the flow rate horsepower. Sometimes there is a large power rise beyond the BEP, especially for the radial tippet and forward curved blades. This is considered undesired because a much larger motor is then needed to provide high flow rate. Backward curved blades typically have their horsepower level of above BEP, non-overloading top of curve. Measure of performance curve, we'll discuss it in the next video part.